Good afternoon, class. Here's exam 3 review covering chapters 3 and 4. Differentiation rules, application of differentiation, and here's part 2, section 3.10, linear approximation and differentials. So we have a curve y equals f of x. So here's the definition for y equals f of x. We define dx called the differential of x by dx equals delta x. So in other words, as we go from one point to the next, P to Q, along the x-axis, we cover what we call the run, delta x dx, or this distance BP, or from x to x plus delta x dc. And dy, called the differential of y by dy equals f prime of x dx. To understand that, first, f prime of x is dy dx, therefore dy is f prime of x dx. Now, graphically, we want to look at two things. We want to look at delta y, which is the rise along the curve, f of x plus delta x minus f of x. So here's f of x plus delta x, this distance. Here's f of x, this distance. So the difference between the two, which becomes BQ, delta y, known as rise along the curve y equals f of x. When we draw a tangent line at point P, the rise along the tangent line AB is equal to dy. That's graphically. We can replace delta y by dy for a function f, which is a continuous and differentiable function with a small delta x if delta y is difficult to evaluate. So dy, which is equal to this distance AB, is not equal to delta y, which is this distance BQ. However, this has been blown out of the proportion for the sake of argument, so we can easily see that dy and delta y are different. However, the smaller the delta x, the closer these two values. Therefore, one, that means dy can approximate delta y because most of the time it's easier to evaluate. Therefore, f prime of x, which is dy dx, is almost delta y delta x, and therefore delta y is f prime of x times delta x. Now, delta y, as mentioned, is f of x plus delta x minus f of x. So if we move things around, that means we pick minus f of x and we take it to the other side, becomes positive. Then f of x plus delta x is f of x plus delta y, precisely. F prime of x is dy dx, meaning dy is f prime of x dx. And now this delta y can be replaced by dy and gives us an approximation. Now, at this point with coordinates a comma f of a, linearization simply means referred to finding the tangent line at some point a. If you look at the point slope, y minus y1 equals m times x minus x of 1. So at this point would be y equals, and you take the y1 to the other side. So y minus y1. So y1 is f of a. M times x minus x of 1, and m is replaced by f prime of a. This is the line that is known as the tangent line. We're going to call it L of x. Rather than memorizing it in this format, just go with the point slope and come up with the equation of a tangent line. Make sure you simplify it and put it in the form of y equals mx plus b. All right, let's look at this example where y equals ln of sine theta, and we want to differentiate first, reminding everybody that for a natural log, we flip this over, 1 over sine theta, and then by the chain rule, the derivative of sine, which is cosine theta. As you know, cosine over sine equals cotangent theta. And we're done with that. What about y equals e to the power of x over 1 plus x? We are going to use the quotient rule. So I'm going to write this as f over g. And we're going to go with f prime g minus g prime f over g squared. So f prime is simply e to the power of x times the denominator g, which is 1 plus x, minus g prime, the derivative of the bottom is simply 1, times the numerator e to the power of x. And now you just write g, the denominator, 1 plus x in a parenthesis and a square. All we have to do is simplify the numerator. By distributing, we get e to the power of x plus e to the power of x times x minus e to the power of x. And obviously, these two cancel each other. So the numerator is e to the power of x times x. We put the x in front, and the final answer y prime is x e to the power of x over 1 plus x quantity squared. Now we are ready to answer this question. Find the differential of each function. So clearly the question was all about the differentials, but the purpose was to mention if you're asked to come up with the differential first, differentiate. In other words, in this case, we are finding dy dx first. So what is the differential? In this case, dy is the same thing times, because the independent variable is theta, this is not dy dx, it's dy d theta, therefore cotangent theta times d theta. Whereas here x is the independent variable. So y prime means dy dx here, therefore it's what we found here times dx. This one times d theta, this one times dx. For y equals x times 4 minus x cubed, find dy. The moment you hear dy, just ignore it and find, in this case, because x is the independent variable, f prime of x or dy dx. And we're going to go with the product rule, obviously, because it's f times g, f is x, and g is 4 minus x quantity cubed. So f prime is simply 1 times g 4 minus x quantity cubed. Now g prime plus 3, 4 minus x squared, the derivative of the inside negative 1 by the chain rule. And this entire thing is g prime now times f x. So if we were to write it, would be f prime g plus g prime f. Now, clearly, between the two, 4 minus x is in common. Are we going to go with exponent 3 or 2? The smaller of the two, namely 4 minus x quantity squared. That is a common factor. So from here, we get 4 minus x. From here, this is gone. We get positive 3 times negative 1 times x, or simply minus 3x. Minus x and minus 3x, they add up to minus 4x. We can put that in front, and we take out the common factor of negative 4 here. And we put that in front. So dy dx becomes minus 4 times x minus 1 times 4 minus x quantity squared. So what we wanted was dy, which is exactly the same thing, times dx. That's the differential. Now we want to find dy and delta y, both of them, at the following values: x equals 5, dx or delta x equals 0.1. So in this case, we are going to replace the x with 5 and dx with 0.1. This is an easy calculation because This is obviously negative 1 quantity squared. The entire thing just becomes 1. And this is 4. So 4 times negative 4 is negative 16. Now negative 16 multiplied by 0.1, you get negative 1.6. So it can easily be calculated. What is delta y? F of x plus delta x minus f of x, which means f of 5 plus 0.1, that means 5.1 minus f of 5. F of 5.1, we have to go back to original function. We replace it with 5.1 and then with 5. This becomes 5.1 times 4 minus 5.1 cubed minus plug in 5 times 4 minus 5 quantity cubed. I hope you see this was easier to calculate. You don't need a calculator, you can do that. This one, 4 minus 5.1, negative 1.1, you have to raise it to the power of 3. You can do it by hand or a calculator. And this one is easy to calculate. 4 minus 5, negative 1 cubed is negative 1 times negative 5. Okay. So we have negative 6.7881 minus 5 or plus 5. We get negative 1.7881. The purpose of this is to show evaluation of dy is easier than evaluation of delta y. As you can see, the two are fairly close. That's why a lot of times this will approximate delta y because it's easier to evaluate. Use differentials to approximate 51 squared. How do we do that? Number one, we need a function. What function? All you have to do, read this. 51 squared. What operation are we dealing with? X squared. So we are dealing with squaring operation. So that operation gives you the function. The next one is to choose a number x, which is close to 51, and we can easily square it. Obviously, the answer is 50 because we should know 50 squared is 2500. Now, what is delta x? The difference between the two, 51 minus 50 equals 1, delta x or dx. I want to make sure we understand the meaning of this. We may not know what's 51 squared, but because dx or delta x is positive, that means 51 squared must be larger than this. That's the idea. If, for example, we were interested in finding 48 squared, I hope you see that dx or delta x becomes negative. By the way, I want to remind you that in when we did the algebra, we would do this in the following manner. You may remember a plus, let me just write this, a plus b squared is a squared plus 2ab plus b squared. So 50 plus 1. So you square this, you get 2500 plus 2 times the first times the last one. 2 times 50 times 1 is 100 plus 1 squared, which is 1. And it 1, let's just write it 1 squared. So 2601. So it's easy to see the exact answer. I assume you can do it in your head fairly fast. So you have an idea what you have, but again, we are going through the process of the differentials, and at this point, f of x plus delta x is simply f of x plus dy. We do have f of x. We are looking for dy. To find dy, first we are going to find f prime of x or dy dx, which is 2x, and dy becomes 2x dx. And now we say, okay, this is x squared. This is 2x dx. Let me erase my work. And so now that we want 51 squared, that means we want f of 51. Okay, so here's x squared. Here's 2x dx or dy. And so f of 51 means f of 50 plus 1. So into this, we replace the x with 50 and dx with 1. Obviously, this is 2500. This is 100, becomes 2600. And as mentioned before, the actual answer is 2601. As you can see, it's extremely close. So using the differentials, we came up with an answer which is very close. And the reason it's close because delta x in a matter of comparison to x is very small. That's why. When it's small, it results in a very good approximation. And we're done with that. But I want to remind you, linearization means find the equation of a tangent line. And equation of a tangent line should result in the same thing. What do we mean by that? Well, we want to find L of x for this function at x equals 50. First, understand what we are going to find. The idea is this. If this is the point of interest when you draw a tangent line, if you pick a number x, whether you use the function or the line, they give you exactly the same answer. But if you're close to it, they are not the same. But if you're close to x, the line and the curve, they give you answers that are very close. That's the idea. Okay? So having said that, L of x we want to find for this one. First of all, what pair you plug in and you get 50, 2500. What is the slope? You put it into f prime of x or dy dx or 2x, 2 times 50 is 100. That's what you do. Instead of memorizing that, I'm going to go with the good old point slope from elementary algebra. Y minus y1. That means y minus 2500 equals m 100 times x minus x of 1, x minus 50. Obviously, this is 100x minus 5 with 3 zeros. And if I move this one, make it positive 2500, L of x becomes 100x minus 2500. And now if I replace the x with 51, I get exactly the same answer as I have here. These two must be identical. Otherwise, we've made a mistake. In other words, the answer you get through the process of using the differential and the answer you get through the process of using linearization or the tangent line, they must be absolutely the same. Use differentials to approximate the square root of 27. Well, we start with the function. What function? Look at the operation. What are we doing? Square root of a number. So that must be square root of x. Now, let's choose a number x close to 27 for which the square root is easy to compute. Obviously, the answer is 25. That's the closest number, and we know the square root is 5. So the closest number. So if that is the case, again, we need to know what's delta x or dx, the difference between the two, 27 minus 25 or 2. Again, meaning we may not know what's square root of 27, but it has to be larger than square root of 25 or 5. Again, just to make sure, if, for example, we were asking for a square root of 24, that means delta x would be -1, okay? 24 minus 25. So pay attention to the sign. That is important, everybody. Okay. So f of x plus delta x is f of x plus dy. We have f of x, but we don't have dy. We are going to find dy by first differentiating. To do so, we're going to write this as x to the power of 1/2. So f prime is 1/2, x to the power of 1/2 minus 1. That means -1/2. You take it down, make it positive 1/2, or 1/2 square root of x. That's f prime. What is dy? Exactly the same thing times dx. And now we have f of x, square root of x, and then we have dy. Okay. Now we are ready to evaluate square root of 27 or f of 27. 27 is the sum of 25 and 2, right? That's the number that we have. 25 is the x, 2 is delta x or dx. So replace the x with 25. Here and here, each one gives you 5, and dx with 2. When we do that, this gives you 5. This gives you 5. These two cancel each other. And we get 5 plus 1/5 or 5 and 1/5 or 5.2. Now I'm setting it up with a decimal representation. Also, now I'm going to use a calculator because of the comparison. If you look at decimal representation 5.1, if you stop here, you have to change it to 2, becomes identical. If you stop here, because of this, you change this to 0, and this one to 2 becomes identical. So that's fairly close. So that's an approximation. And again, we're going to use linearization. And to use linearization, that means find the tangent line. To find the tangent line, or L of x, you need a function. Here's your function. F of x is square root of x. You need a point at x equals 25 if you plug in. So when you plug in, you get 5. That means the pair is 25, comma 5. And then if you plug it into f prime of x right here, you get the slope. If I put 25 here, I get 5. Times 2 is 10, so 1 over 10. Therefore, L of x is of interest to us at the pair 25, comma 5 with the slope being f prime of 25 or 1 over 10. And again, I'm not going to go with this. I'm going to just go with a good old point slope. So y minus y1, that means y minus 5 equals m 1 over 10. X minus x of 1, that means x minus 25. So this is 1 over 10 times x minus 25 over 10 plus 5. We're going to combine these two, and we get 5 halves, because this one, both of them divisible by 5. We get 5 over 2. So minus 5 halves plus 5 halves is plus 5 halves. Let me erase my work. So L of x is 1 over 10 times x plus 5 halves. I'm just plugging 27. You get 27 times 1 over 10 plus 5 halves. And I'm going to leave it for you to verify. You get 5 and 1/5 or 5.2. You must get exactly the same answer, everyone. All right, one more example. Use differentials to approximate cube root of 63.5. And again, we're going to start with the function. What function? Just read. What is the action? Cube root. What is the operation or action? Cube root of x. Now choose a number. Let's come up with a number closest to 63.5 for which the cube root is easy to compute. Obviously, the answer is 64 because we should know cube root of 64 is 4. And so now dx or delta x would be the difference between the two, which gives us negative 0.5. dx or delta x is 63.5 minus 64 is negative 0.5. For example, if it was cube root of 65, delta x would be positive 1. So now we have f of x plus delta x, which is f of x plus dy. We do have f of x to be cube root of x. We don't have dy. We need to find it. To find dy, we're going to go with f prime of x first. To go with f prime of x to differentiate this, we're going to rewrite this as x to the power of 1/3. So its derivative is 1/3 x to the power of negative 2/3. And this comes down here and takes a positive 2/3 as the exponent, or 1/3 cube root of x quantity squared. This is f prime. What is dy? Exactly the same thing times dx. Therefore, we have f of x, we have dy. Let's replace. Now, cube root of 63.5 means f of 63.5 means f of 64 plus negative 0.5. This is x. This is dx or delta x. So, going back to this, we're going to replace the x in both cases with 64 and the x with negative 0.5. So clearly this is 4. And so is this one. When you square it, you get 16. So this is 4. This is 4 squared, 16 times 3, 48. We're going to put plus, minus, minus, and I'm going to replace the 0.5 with 1/2 because I want to write the fractional format so we don't need a calculator first. Meaning, as you can see, this is a complex fraction, 1/2 times 48 or 1/96. 4 minus 1/96, we can write it as 3 and 95/96. In other words, to calculate this one, from here, we don't need a calculator. I'm putting it in a decimal format because I want to compare to actually putting this into a calculator to see how close they are. But please understand, as far as we are concerned, we get to this answer, which is a perfect answer, okay? This one is now because I want to compare. So if I use a calculator for cube root of 63.5 with a bunch of decimals, I get this one. Take a look. 989, 989. After 9 comes 5. After 9 comes 5. After 5 comes 5. So if I stop here, this has to be changed to 6. If I stop here, it has to be changed to 6. That's how close they are. Again, why is that? Because dx or delta x compared to the choice of x, which is 64, is extremely small. So the approximation is very good. And we're done with that. And what I want to do again, I want to go over the linearization. That means I want to find the equation of a tangent line, in which case we need to know L of x for what function? This function, cube root of x. At what point? At x equals 64. That's what we want to find. Okay, so what is the pair? Obviously, when you plug in 64, you get 4. So the pair is 64 comma 4. What is the slope? If we go back here, f prime of x, replace it with 64. Remember, this becomes what? 4 squared, 16 times 3. This is 48. So 1 over 48. So L of x is of interest to us at the following pair, 64 comma 4, with m being f prime of 64 or 1 over 48. So again, I'm not going to go with this formula because I've seen students sometimes memorize that without really understanding what's going on. So just go with the point slope y minus y1. That means y minus 4 equals m 1 over 48 x minus x of 1. That means 64. If I distribute again 1 over 48 times x minus 64 over 48 minus 4 moves becomes positive 4. This one, they are both divisible by 16 minus 4 thirds. This one, 12 thirds. They add up to 8 thirds. And I'm going to leave it for you to plug in 63.5. Make sure you plug in 63.5. You get 63.5 over 48. Multiply the top and the bottom by 2, and the denominator becomes 96. You can combine these two, and you will get this one, exact answer. Okay? So definitely, I would like you to try that. So that's the concept of differential and linearization, and it has a lot of usage. It also has usage in applications. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differential to find the approximate change in the area of a cross-section of the vessel. So here's the cross-section in the form of a circle, and it has some radius. Then it shrinks, and now it has a new radius, which is smaller. And this difference between the two is dr. So r is 1.4, and dr is the difference between the two, which is negative 0.1. We should know we're talking about the area, and area of a circle is pi r squared, and we want to find dA. So given r is 1.4 millimeters, dr is the difference between the two. 1.3 minus the original one, negative 0.1 is shrinking. That means dA becomes negative. A equals pi r squared. We want to find dA. That means we want to approximate the shaded region. You see this region? We just want to shade it. We're going to look at the shaded region. So having said that, we know the area is pi r squared. And in order to find the A, reminding everyone f prime is dy dx, that means dy is f prime of x dx. So A prime of r is dA dr. That means dA is the A prime of, see, dy is the product of these two, dA is the product of these two. So first we're going to differentiate and find the A dr or A prime of r. And to do so, we start with pi r squared, and pi, everybody, pi is a coefficient, it's a multiplier, it remains. So you really differentiate r squared, which becomes 2r. So you get 2 pi r. So that's dA dr. What is dA? Exactly the same thing times dr. So this is 2 pi r, and dA is 2 pi r dr. Now, the given will help. Replace the r with 1.4 and dr with negative 0.1. We get negative 0.28 pi, precisely millimeters squared. If they want an approximation, remember in calculus, we always go with an exact answer. You put it into a calculator with a bunch of decimals, negative 0.8796 millimeters squared. Now, what does it mean? The area of the cross section of the vessel is decreasing. Why is it decreasing? Because this is negative. By how much? By this, by 0.28 millimeters squared. Bear in mind, when we mention decreasing, we make sure this is positive because decreasing will negate the value. So we don't do negative times negative is positive. Okay, so decreasing is positive. Now, this is easy enough that the shaded region, we can come up with the exact answer, delta A. What is the exact answer? Well, pi r squared. Use 1.3, so pi times 1.3 squared. Minus pi r squared. Use 1.4. So pi times 1.4 quantity squared, the difference. So I have factored out the pi, 1.3 squared minus 1.4 squared. And look at this, how close it is. Negative 0.27 pi millimeters squared. Again, this is easy enough that delta is really not too bad. But understand delta A and dA are close, and that's the idea here. A bacterial colony has a population of P of t equals 20t over 10 plus t squared in millions. T hours after a nutrient is introduced, use differential to approximate the change from 2 to 2.4 hours. So t is 2. This difference is dt or delta t. And approximate change, that means find dp. So P of t is given. If we differentiate it, a P prime or dP dt, and dP would be P prime of t dt. In other words, we are showing, as we have seen, dy is f prime of x dx, dP is P prime of t dt. That's the concept. And so to take care of that, we are going to go with differentiation first, never mind dP. Let's go with P prime, and that is going to use the quotient rule. And so having said that, f prime g minus g prime f over g squared. So f prime is 20 times g is 10 plus t squared minus g prime is simply minus 2t times f, which is 20t, and put the denominator here in a parentheses and square. So to simplify, we are going to distribute, and we are going to get 200 plus 20t squared minus 40t squared. These two combine. This is what we get, 200 minus 20t squared over 10 plus t squared quantity squared. And what is dP? It's exactly the same thing times dt. So we're going to go back to given and replace the t with 2 and dt with 0.4. This is 2 squared. 4 times 20 is 80. 200 minus that is 120. 2 squared 4 plus 10 is 14. Squared is 196. So the ratio of the 2 times 0.4 gives us 0.245 millions of bacteria. That means 245,000. This means 245,000. So that means the population of the bacteria colony is increasing by 245,000. Why is it increasing? This is positive. Can we find the exact answer? Well, yes. Just plug in 2.4 and then plug into the difference. So P, delta P, is P of 2.4 minus P of 2. I'm going to leave it for you to verify. It's 0.189, which means 189,000. This is 0.189 million. Measurement error. In a manufacturing process, ball bearing must be made with a radius of 0.6 millimeter with a maximum error of plus minus 0.015 millimeter. Use differentials to estimate the maximum error in the volume of the ball bearing. So as you can see, they are in the shape of a spherical shape. And if they are too big, they get stuck. This doesn't turn. And if it's too small, they fall off. That's the idea. So it's a spherical shape. It's either too small or too large. By this much, plus minus 0.15 is okay. So R is 0.6, delta R or dr is this much, plus minus 0.015. And we are supposed to know the volume is 4 thirds power cube because it's a spherical shape. And dV is of interest to us. So understanding the question. So if V is a 4 thirds power cube, what is dV? So first, we're going to go with V prime of R or dV dr, which means we're going to start with 4 thirds pi as a coefficient and differentiate R cubed, you get 3R squared. This becomes 4 pi R squared. This is V prime or dV dr. So what is dV? 4 pi R squared dr. Plug in. What is R? 0.6. What is dr? Plus minus 0.015. Put it into a calculator. Plus minus 0.0216 pi. You can use a few decimals. Plus minus 0.0678584 millimeters cubed. And by the way, you always show the exact answer you find. Now, again, this is not too bad. We can find the exact value, which is delta V, meaning if the volume is 4 thirds power cubed, we can plug in 0.6 and that gives us the volume that it should be. Then there are two calculations we need to do. One of them is besides that. So 0.6 plus 0.015 becomes 0.615. Put it in there, find the volume, and the difference is on the plus side, 0.0221 pi. On the other hand, subtract this from it. This is minus, and you get 0.585 and put it into this. And again, I've noticed 4 thirds pi. I have factored it out. And on the negative side is negative 0.0211 pi. That's the idea that we have here. So we can find the exact answer, the approximation. As you can see, it's extremely close to both numbers. For y equals f of x equals sine x, find dy. Well, again, let's go with f prime of x dy dx, which happen to be cosine x. We already know that. So what is dy? The same thing times dx. So dy is simply f prime of x dx or cosine x dx. Now, find its linearization at pi over 6. Linearization means find the equation of a tangent line. So at pi over 6, we need two things. We need a pair, okay, and we need this slope. So f prime is cosine x, so you put it in there, and that gives you square root of 3 over 2, and that's your slope. As far as the pair is concerned, when x is a pi over 6, then f of x is sine x, sine of power 6 or 1/2. So you have the pair, power 6 1/2, and you have the slope. Again, I'm going to go with the point slope. Y minus y1 is 1/2 equals m squared of 3/2 x minus x of 1, x minus power 6. So multiply these two, minus 1/2 moves, becomes plus 1/2. So y or L of x is, if we distribute square root of 3/2 x, if you multiply these two, you get minus square root of 3 pi over 12 plus 1/2, and you leave it as that because this is exact approximation. Remember, pi is about 3.14159. So multiply by square root of 3, divide by 12, negate that, plus 1/2. So that gives you a number. I want you to know that. So that would be mx plus b, whatever that number is, minus whatever is the b. But I want to keep it as that, which is then exact answer. Now, we want to use this concept and approximate 31 degrees. Remember, pi over 6 is 30 degrees. Okay? So the difference is 1 degree, and we're going to go with the radians. So sine of 31 degrees is sine of 31 pi over 180, and I'm going to look at it both ways. Again, 31 degrees, remember, pi over 6 is 30 degrees, 31 degrees is close. We're going to go with the radians. So sine of 31 is sine of pi over 6 plus pi over 180. So f of x plus delta x is f of x plus dy. Okay, all right. So we want this one, right? So f of x is sine x, dy is cosine x dx. So I'm using the differential. So sine of pi over 6, cosine of pi over 6, and dx is pi over 180. At this point, of course, we know this is 1/2, and we know this is square root of 3/2, pi over 180. Put this into a calculator, everybody. Okay. And we get about 0.5151 if we go with 4 decimals. Now, if you put sine of 31 degrees, it has to be in degree mode. Okay, you can see the answer from the calculator. Okay. Now, sine of 31 is sine of 31 pi over 180, as it was mentioned. And to use the linearization, replace the x with 31 pi over 180. So we get L of 31 pi over 180 equals square root of 3 over 2, 31 pi over 180, minus square root of 3 pi over 2 plus 1 over 2. You have to use a calculator. And this, again, we use 4 decimals here, must give you an exact answer as that. If you put 31 degrees, sine of 31 degrees into a calculator, notice how close they are. 0.5150381. So the first three are identical. That is extremely close. That's a very good calculation, again, because 1 degree compared to 30 degrees, it's a very small dx or delta x, and therefore it gives a very good approximation, everybody. One side of a right triangle is known to be 20 centimeters long, and the opposite angle is measured at as 30 degrees with a possible error of plus minus 1 degree. Use differential to estimate the error in computing the length of the hypotenuse. So you have to set up a drawing, and you have to define your variables. So here's a right triangle. Here's a 30-degree angle. Okay. 20 centimeters is opposite that. The length of hypothesis is missing. We call it x. And this has a possible error of plus minus 1 degree. So we're going to say, well, one leg, the leg is 20 centimeters. Opposite angle theta, which is 30. And this creates this plus minus 1 degree as d theta. And we want to find the error in x or dx. So we're going to write, given one leg is 20 centimeters, opposite the angle of theta, which is 30 degrees, d theta is plus minus 1 degrees or plus minus pi over 180. We're going to go with the radians, where we want to find the estimate the error in the hypotenuse, so we want dx. Now, in a related rate, we have to, in this case, relate what we know and what is missing. In this case, x and the angle. As you can see, sine theta is the opposite over the hypotenuse. So sine theta is 20 over x. So x is 20. Let me just write that and then. So that means x is 20 over sine theta. As you know, sine is 1 over cosecant, so x is 20 cosecant theta. And now if we want to differentiate this with respect to theta, dx d theta is 20 times the derivative of cosecant is negative cosecant theta cotangent theta. Let me erase my work so we can use this space here. So what is dx? Product of these two. Minus 20 cosecant theta cotangent theta d theta. So plug in. What is theta? 30 degrees or pi over 6. What is d theta? Plus minus pi over 180. So we're going to plug in. Now, cosecant, as mentioned, what is 1 over sine? Remember, sine of pi over 6, we know it's 1/2. Therefore, this is 2. Cotangent of pi over 6 is square root of 3. So those two we plug in, and now we have to put it into a calculator. This is minus 4d square root of 3. And again, doesn't matter, it's minus plus times plus minus still plus minus or minus plus. So plus 2 square root of 3 pi over 9 precisely. We put that into a calculator and we get plus minus 1.21 centimeters. So what would be the amount of error in the hypotenuse with a plus minus 1 degree? About 1.21 centimeters. What is the percentage error? Let me again erase my work. When we look at the relative error or percent error, that means the ratio between, in this case, dx and x. So dx you can use this, but if you want to go with the exact, you can put this one or this one. But what about x? Do we know what's x? Sine theta is 20 over x. X is 20 divided by sine theta. Sine theta is 1/2. Or you can say 20 times cosecant theta. Remember, cosecant is 2. Sine is 1/2 or pi over 6. So x is 20 times 2. Okay, so theta is 30 degrees or pi over 6. X equals 20 times 2. And I hope everybody is okay with that. It's just explained here. 20. Okay, x is 20 times cosecant theta, or 20 divided by sine theta, 20 divided by 1/2. And so you simplify everything, you get plus minus the square root of 3 pi over 180. This is the exact answer, and you put it into a calculator, roughly plus minus 0.03 or plus minus 3%. That's the relative error or percent error.